right, this ed puzzle is about Ohm's Law. Some of you have not had much practice with it, so I'll just talk about it real quick. We're going to do Ohm's Law, and we're going to do some circuits. V equals IR is Ohm's Law. Voltage, another word for voltage is potential difference. This is basically the force that your battery can push electrons with, or a source can. Amps is I. Amps is the amount of current, the amount of electrons flowing through a wire, and R is the resistance to that current. So volts, amps, and resistance is in something called ohms. Okay? Volts, amps, and ohms. Ohms spelled like this. So if you have a wire, if you have a 6-volt battery, and it's only pushing 2 amps of current out of it, then the resistor, or the light bulb that the current's going through, must be a resistor with 3 ohms of resistance. That's how simple Ohm's law is. Now let's take a look at it as part of a circuit. This symbol right here is the symbol for your voltage source, whether it's a battery or something you plug in a wall. And this line I'm drawing is the symbol for the electrical wire. Now, if I put a circle with an X in it, here are some symbols you can see up here. Circle with an X means a resistor. Circle with a loop means a resistor, but this is always particularly a light bulb. A circle with an M is also a resistor, but that means electric motor. And then just this symbol right here means resistor of some type, okay? So we could say this is a light bulb. So in other words, any of these symbols can be used and it still means the same thing. It means some resistor with a certain amount of ohms of resistance. Now, so if we look at this right here, here is a circuit. This is a 6-volt battery. We can test the wire right there and say 2 amps of current are going through it. So that means this is a 3 ohm resistor. See, that's the last problem that we just did. Does that make sense? Now, what if there was another resistor added to this circuit? Another 3 ohm resistor. Then that would change the amount of amperage in the circuit. Now, you can think of electrons as going this way or going this way. It doesn't matter. Okay? It doesn't matter. It's a complete circle, so the current in the wire is going to be the same everywhere. It's not any different between the 2 resistors or before the resistor or anything like that. So let's see. We have a 6-volt battery, and let's look at the resistance. 3, the electron has to go through this resistor and then also through this one. So you would add these up, 3 plus 3, 6 ohms of resistance. So now it would be a 1 amp current. So if you think about it, this battery right here is actually giving out less current if there's 2 bulbs. Now, if you've been in class, you would know that the catch is both of these bulbs are now burning more dimly than if there were 1 bulb. So having 2 dim bulbs is actually using less current, less amperage, so the battery would actually last longer. That's kind of freaky-deaky, isn't it? Check this out. And I'm making this just a super quick, simple lesson. Let's say now, here's our voltage source. 12-volt battery. We're going to go around here, and I'll go here, and then we'll go right here. We'll go right here. We'll go right here. Now, see this symbol right here? This is the symbol for a switch. This switch is in the open position, so guess what? No lights would be on, because the electrons cannot go in a circle and get back to the battery. So we would have to turn the switch to the on position, right? We'd have to think about it being like that. So if this switch was on, and this was a 1 ohm resistor, a 2 ohm resistor, and I'm trying to use simple numbers so that you can do a lot of this in your head, and a 3 ohm resistor, what is the current in the wire at this point? How many amps? Okay, we're going to use Ohm's law. V equals IR. 12 volts equals some current times our resistance is 1 plus 2 plus 3. 6 ohms of resistance. Therefore, the current is equal to 2 amps. So we have 2 amps here. If we tested the current here, it would be 2 amps. It would be 2 amps here. It would be 2 amps here. Now, what happens if we open the switch up again and the switch goes back to that position? Yeah, all the lights go out. All of these lights go out. This one switch can only control all the lights. What if I put a switch right here and opened it up right there? All the lights still go out. All of the lights still go out. There's no way to just turn one of these bulbs on at a time because this is a series circuit, which means that the electrons have to go through all of these bulbs in a row. So what do we do to fix that? We create a different type of circuit. Now let's say we have a 12-volt battery. There's my symbol for voltage. And now I'm going to make one wire go up like this and another wire go up like this. Now these two wires are in parallel. Okay? Parallel. These two wires are in parallel. So now any bulb that we put, let's put our 1 ohm bulb, our 2 ohm bulb, and our 3 ohm bulb. Let's put those bulbs right here in the middle. Now, if we just touch a wire to each side here, that bulb would be on. See how we can go in a circle? Does that make sense? The current right here would be V is equal to IR. There'd be a 12 amp current right there. Let's connect this bulb to the battery. Boom. Boom. What is the current right here? 12 volts. Oh, this is going to be 6 amps of current. And what if we connect this guy right here? 12 volt, 12, 3. It's going to be 4 amps of current. Now let me ask you a question. If I put a switch right here, boom, and opened it up, all of these light bulbs would go out. But what if I put a switch right here? Would these two light bulbs go out? No, they wouldn't. If you put a switch right here, then only this light bulb goes on and off. Put a switch there, put a switch there. Now we control these light bulbs individually. This bulb doesn't care if those two bulbs are there or not. Look, it can still get to the battery. So all of these bulbs still can touch the 12-volt wires. The other bulbs are not in their way. That's what being in parallel means. This bulb feels like it's the only bulb, no matter what these guys are doing. These bulbs would all burn brightly. They would all burn brightly because they're all hooked up directly to the 12-volt source. So let me ask you some questions now. What is the current in the wire here? Well, the only bulb in the way of the wire right there is that bulb, so it's 4 amps there. Now, if we go right here, the current right here is 6 amps because this is the only bulb on this little circuit. So what is the current in the wire right here? Yep, it's 10 amps because these electrons are going through the wire and these electrons are going through the wire. 4 plus 6 is 10 amps. What is the current in the wire right here? Well, it's the 4 amp bulb is going through the wire here. The 6 amp bulb is going through the wire here. And the 12 amp bulb is going through the wire here. 22 amps of current are being pushed out by this. This thing's going to go dead pretty quickly, right? Now, if I put a switch right here and opened it up, it controls all of these bulbs that are in parallel. So here's what I want you to pretend. This is your bedroom. This is your brother or sister's bedroom. and this is your parents' bedroom. If we put a switch right here, it will cut all of these lights off. The name of this switch is what? You got to guess? Yeah, that switch in your house is called the circuit breaker. And it only goes off when you have too many things turned on. That's parallel and series circuits, and that's a quick little tutor. If you haven't been physically in the classroom, this should really have helped you.